Hello my dear students, this is the second session of structure of an atom. In the first session we studied about the discovery of electrons and protons. Okay, so in the last chapter we have studied about the Dalton's atomic theory. So he stated that the atom was indivisible and indestructible. Okay, but when the electrons and protons were discovered, so this Dalton's atomic theory was failed. And later on other scientists they wanted to know about the how electrons and protons are arranged within the atom. So they proposed some of the models. So various atomic models were proposed. So the very first scientist called J.J. Thomson, he proposed a model for the structure of an atom, that is the Thomson model. So in this model he compared his model to the pudding. Here you can see the plum pudding. Okay, he told it is similar to that of the Christmas pudding. Here the electrons in a sphere of positive charge. He took a sphere which is positively charged. The sphere is positive charge and the electrons are embedded in the sphere. Okay, like you can see here the dry fruits, they are embedded in the cake. So likewise the electrons are embedded in the positively charged sphere. You can imagine a watermelon. Here you can see the red part of the watermelon. Red is the edible part of the watermelon. So that red part is the positively charged sphere. And you can see the seeds. So these seeds are the electrons. Okay, so he proposed that the atom consists of the positively charged sphere and the electrons are embedded in it. And the positive charge and the negative charge, they are equal in magnitude. They are equal in magnitude. Hence, the atom is electrically neutral. Okay, but Thomson cannot explain the stability of the atom. Okay, even though he explained that atoms are electrically neutral, he could not explain the stability of the atom. Hence, this model was failed. Next scientist named Ernst Rutherford, he proposed a model called Rutherford model of an atom. So he was very much interested in knowing how the electrons were arranged in the atom. So he designed an experiment. In his experiment, he used the alpha particles. So these alpha particles, they are the fast moving particles and they are doubly charged helium ions. They are the doubly charged helium ions. So these alpha particles are nothing but the helium nucleus. So the mass is 4 unit and they have some amount of energy. So what he did, he took a thin gold foil. Okay, this is the gold foil. So which consists of 1000 atoms. So he took such a thin gold foil. And this is the source of the alpha particles. And here the circular fluorescent screen is placed. This is the circular fluorescent screen. So what he did, he passed the alpha particles through the gold foil. So when he passed, some rays were undeflected, means they did not change the direction. They passed through the gold foil. Here you can see the rays are passed from the gold foil. And some rays were deflected back. That means they changed the direction. Okay. So most of the alpha particles, they passed in a straight line. Here you can see they have passed through the straight line. They did not change the direction. And some of the alpha particles, they deflected by small angles. You can see they have deflected in a very small angle. And 1 out of 12,000 particles, they appear to rebound. So the particles touch the gold foil and it has rebounded back. Okay. So by this he concluded that, so first you observed that the rays passed through the gold foil. So this indicates that the space is present inside the atom. Okay. So the space is present inside the atom, hence the alpha particles pass through the gold foil without changing the direction. Next, few particles, they deflected in a small angle. So this indicates that the positive charge of the atom occupies very little space. Okay. Next, 1 out of 12,000, it rebounded, right? So what does that indicated? It rebounded by 180 degrees Celsius. So this indicates that the positive charge and mass of the gold atom, it was concentrated in a very small volume within the atom. Okay. So the Rutherford nuclear model proposes that there is a positively charged center in the atom called nucleus. So at the center there is a charged part called the nucleus. So nearly all the mass of an atom resides in the nucleus only, and the electrons will be revolving around the nucleus in a circular paths. Okay, the electrons will be revolving in a circular paths around the nucleus. And the size of the nucleus is small as compared to the size of the atom. So when you compare the size of the whole atom, the nucleus size is small. So this was the proposed by Rutherford. So there were some drawbacks in his model. So according to electromagnetic theory, what happens when any charged particle is moving in a circular orbit? Okay, when any charged particle if it is moving in a circular orbit, it will have some acceleration. So when it is moving in a circular path, it will emit radiation. The charged particle will emit the radiation. So when it emits the radiation, it will lose the energy. It will loses energy. So when it loses energy, it cannot move along the circular path. It will collapse and falls at the center. Okay, same thing here. When any charge, so this principle was used here. When any charged particle, if it is traveling in a circular path, it will emit radiation. So the electron, when it is moving in a circular path, it will emit radiation and it will lose energy. So when it loses energy, it will come and fall at the center of the nucleus. So when electron comes and falls at the center of the nucleus, the atom will not exist, right? So if the atom will not exist, then the matter will not exist, because matter is made up of atom. So the matter won't exist. Okay, so if matter won't exist, nothing will be there in the nature, right? So he could not explain the stability of the atom. Hence this model was failed. Clear? So the next scientist called Niels Bohr, he proposed a model, that is Bohr's model. So in order to overcome the objections raised against the Rutherford, Niels Bohr proposed some of the postulates. So the first postulate is only certain special orbits known as discrete orbits of electrons are allowed inside the atom. Okay. So the discrete orbits are present inside the atom. While revolving in discrete orbits, the electrons do not radiate energy. So when the electrons are revolving in these orbits, the electrons will not radiate energy. So if they will not radiate energy, they don't lose the energy. Hence they will not collapse. So only in the discrete orbits, the electrons will be revolving. So these orbits or shells are called as energy shells or the energy levels. And these energy levels are, these energy shells, they are represented by K shell, L shell, M shell and N shell. So the first shell, this is known as K shell, and the second shell, L shell, third shell is M shell, and fourth shell is N shell. Okay, here N equals to 1, 2, 3, 4. So this continues. Okay, N equals to 1 means the first orbit. N equals to 2 means the second orbit or the second shell, you can tell. So the first shell is K shell. N equals to 1 means K shell. N equals to 2 means L shell. N equals to 3 means M shell. N equals to 4, the fourth shell, that is the N shell. So the Bohr told that the electrons will revolve in a discrete orbit. So when they revolve in a discrete orbit, they don't radiate the energy. Hence the atom is very stable. Okay. We'll stop here. We'll continue in the next session. Thank you.